It is a segment with endpoints on the circle. Colton, did you have a different answer you were going to give me? Okay. So it does need to be a segment with endpoints on the circle. It doesn't go through, otherwise it's a secant. I see what I know what you're trying to say. Okay. This is a chord. I actually thought you were going to be honoring and tell me something about music.
No. That's what I was going to say, but I don't. Do you have what? Pencil.
Back off and give it back. I don't think I didn't forget about that.
It's so small. I know you're racing.
Using the word chord, who can give me the definition of a diameter? A chord goes through the center. So we have some theorems that we need to talk about. Okay. The first one is the congruent corresponding chord theorem. Okay. And this says if we have in the same circle or congruent circles two minor arcs are congruent if and only if their corresponding chords are congruent. So if and only if means this sentence can be read either way. If we have two minor chords that are congruent, then, excuse me, if two minor arcs are congruent, then the chords are congruent. Or if we have two congruent chords, then their minor arcs are congruent. So I'm going to zoom in on this circle right here. Okay. Because I have two chords that are congruent, then the arcs that correspond with them, those are going to be congruent. Okay. Now, in our last section, what we just did in our warm-up, we talked about measuring those arcs using degree measurements based on central angles. Okay. So are we all okay with arcs get measured in degrees? Okay. So I'm going to draw a picture here of a circle. Okay. And what is true in this circle is that the arc AD is 30 degrees. And we know that each of these three chords are congruent. So I want you to draw this. And I will wait for you to draw it so that we can work through this circle problem together. What? C is my center. Now I'm missing it. What's wrong?
The paper is frustrating me.
Oh, don't write so hard.
No, I wasn't trying to, but they like, it uses the paper where it's like not normal. It's like
Sorry.
thinner.
I'm sorry.
Yeah, this paper is like thinner than the normal.
I know. All right. Now, all of the arcs together add up to be what? 360 degrees. So I know that since these three segments are congruent, then these three arcs are congruent. So if I want to know their measurement, I don't know. Can I call them X? Okay. And I know that my three arcs plus 30 degrees should add up to be 360. Right? So each of those arcs equal 110 degrees. If you have two chords that are congruent, you can assume by this theorem that the arcs are the same measure. Also, if you have two arcs that are the same measure, you can assume because of this theorem that the chords are congruent. Feel some? Lisa? Okay. The next thing on the next page, if a diameter is perpendicular to a chord, then the diameter is bisecting the chord and its arc. So I want you to, I'm going to zoom in on this, okay? Because we have a diameter perpendicular to the chord, that means that these two pieces are the same. It also means that these two arcs have the same measure. Then, all right now, if we have time. Okay, so we're gonna draw a circle that has a diameter Okay. So this cute little guy right here is X. Okay. We need to find X. And I am telling you that DF is 16 and GE is 10. GE is 20. That sounds good. Sorry about that. How am I going to find X? So first of all, because we have the diameter perpendicular to the chord, what is true about that chord?
It's also on the other side.
this whole thing is 16, right? What's true about this piece?
And it goes down the middle of it.
Okay, it's bisecting it. So each of these pieces are 8. Okay. DF is 16. Yep. DF is 16. And since it's perpendicular to our diameter, it is bisecting it. So these are each 8. Do you have a question about the problem? Okay. So I know that this is 8. How am I going to find this?
The diameter, then
Radius.
radius should be half of that, so you can make it.
Okay, I'm gonna go C to D because I have more room that way. But we know that each radius is 10. Since GE is 20, GE is our diameter. So I know each radius is 10. So Layla said, hey, draw in a radius. And now we have a right triangle. What?
Isn't that 90? Oh, wait, no.
Well, this guy is 90 degrees.
But then that means that the other side.
No, because it has to be the central angle.
X equals 6.
Like this is 90, yeah. Oh, all these are 90, yeah.
So doesn't that make DE 90?
No, because it's not a central angle. It has to be this, it has to be at the center. So this angle tells us what DE is. Okay. All right. So we can say that 8 squared plus x squared is 10 squared. Six.
Like DE, like do you see DE that one?
Oh yeah, no. Okay, so now we can also use this in written as the converse, okay? So this theorem we can apply both ways. If we have a chord that is perpendicular and it's getting bisected, then we know that SQ is the diameter. Okay, so this can go both ways. Okay. Now, the last thing that we're going to talk about are these equidistant chords. Okay. In the same circle, 2 chords are congruent if and only if they are equidistant from the center. What does that mean? Let me show you. That's not a good circle. There we go. Distance is measured with writing. So first I want you to just draw this. Okay.
He left in 6th period.
I haven't seen him.
You're third in line. buddy.
Tangerine.
I still have to fill my water jar.
Not yet.
And you're behind me because I have to fill my water. Yeah.
Prices first.
I know.
Okay. Okay, so what I want you to do, I am telling you that CA is 42 And I am telling you that the arc CT is 124 degrees. Okay, because the chords CA and CT are the same distance from the center. Do you see that? They're the same distance. Number one, there's the tick marks. Number two, we need them to be perpendicular because that's how distance is measured, perpendicularly. Okay, so I know that CT is also 42. Those chords are going to be congruent. I also know that the measure of arc CA is also going to be 124 degrees. Which would make the measure of arc AT what?
No. Oh, wait, no, that's the wrong way.
360 minus 248.
112.
112?
It'd be 112. It'd be
112?
Yes.
360 minus
I'm gonna-
124 minus 124.
112.
112. Okay. What you are going to do for me. Your homework, turn the page. Is page 292. You may begin on that right now. Right.